Welcome to lesson 6.3, solving equations involving integers. So this lesson we are just learning another strategy or a different way or a different method that we can use to solve algebraic equations. So in this lesson we're going to use algebra tiles and inspection to solve equations involving integers. And if you recall back to our unit on integers, an integer is just any whole number that could be positive or negative. So -4 is an integer. +4 is an integer. And by now we've used algebra tiles in a few different units as well. We've used algebra tiles when we did our our integers unit, and we also used algebra tiles in the previous unit, unit 1 that we just did. So just a quick little review about algebra tiles. If you recall our long rectangular yellow tile, do you remember what that represented? So your long rectangular yellow tiles represent your variable. And we also have our small unit tiles. And if you recall, your small square yellow tiles represents +1. And then we didn't use the red tiles last unit, but we're reintroducing them this unit. And if you recall, our yellow tiles represent -1. So those are the three different algebra tiles that we're going to be using for this lesson. So we're going to go over an example together. First, reading the word problem, creating the algebraic equation for it, and then taking it the next step further and using algebra tiles to actually solve the equation. So I've pulled this example from page 231 and 232 in your textbook. If you want to follow along, you're more than welcome to. So our question says, Michaela has a collection of old pennies. She sells 3 pennies to another collector. So I'm just going to underline sells 3 pennies because I think that's a pretty important part of this equation. Michaela then has 10 pennies left. So I'm going to underline that because, again, I think that's a pretty important part of the equation. How many pennies did she have before she made the sale? So I'm going to now use this word problem and the information that I've underlined to come up with an algebraic equation. So my first step in creating the equation, I'm looking for the information that's going to represent your variable. I'm going to look for the information that's representing the constant term or the thing that's staying the same, and then also what the equation equals. So just by looking at this, I can see Michaela then has 10 pennies left. To me, that represents what it equals, how many she has left. That's kind of the end product. I can see that she sells 10 pennies to another collector, and I know that we're looking for how many pennies did she have before the sale. So this part of our equation here is going to be our variable because we don't know how many pennies she had before the sale. So maybe I'll use P for pennies. And then I know that she sells 3 pennies to another collector. So I'm thinking in my head, okay, what operation does sells 3 pennies represent? Is it adding, subtracting, multiplying, or dividing? If somebody sells 3 pennies, they're giving them away, or they're getting rid of them, sorry. So I know that's going to represent a subtraction. So P subtract 3 equals 10, or in other words, the amount of pennies she had before the sale, then she sold 3 pennies, and now she has 10 left over. So we've done the first step in actually creating our algebraic equation, and then in the next slide we're going to use algebra tiles, and we're going to walk through how that would look to actually solve this equation. So one way that we can solve this equation, P minus 3 equals 10, is to use algebra tiles. And so algebra tiles, just as a review, is a more visual way to solve an equation using pictures or symbols. So the first thing that I'm going to do is I'm going to draw a vertical line down the middle of my page. And as we recall in our previous unit, that represents your equal sign. So if we look at our equation, on one side of our equal sign we have P subtract 3, and then on the other side of our equal sign we have 10. So now this is where the algebra tiles come into play because we need to draw that out or represent that using the tiles. So we know that we have one variable. So I'm going to draw one long rectangular yellow tile tile because we know that those tiles represent a variable. And because I only have one P, I'm only drawing one rectangular tile. I then see that we have 3 negative units because it's P subtract 3. So we have 3 negative units there. So I need to draw 3 small square tiles, but I need to draw them in red because we know that each red one equals a negative unit. If I was to draw yellow, that would represent positive, but I can see that it's P subtract 3, so we need to use our red tiles to represent negative. And then on the other side of our equation, we have 10. And so 10 in this case is represented as a positive number, so I need to draw 10 positive squares over on this side. So 3, 4, 5, 6, 7, 8, 9, 10. So I've now visually represented my equation using algebra tiles. So this represents P minus 3 equals 10. So our next step is we need to isolate our variable. And what I mean by isolate the variable is we want to know what does P equal. And I don't know what that equals until I get rid of these 3 negative tiles somehow. Because right now P subtract 3 equals 10. I don't want to know what P subtract 3 equals. I want to know what P equals. So we need to isolate our variable or get the variable by itself on that one side of the equation. So I see that I have these negative 3 tiles that are kind of in the way that are making that not possible for me right now. If you recall back to the unit we did on integers, I see that I have negative 3 on this side, and I want to essentially make that 0, because if I can make these negative 3 equal 0, then I all of a sudden have my variable by itself and it's isolated and I can solve for it. So what did we have to do? If you can remember back to the unit on integers, what do I have to do to these 3 negative tiles to make them equal 0? So if you remember back to that unit, we have to add 0 pairs. So how do you make a 0 pair? Any negative 1 unit combined with a positive 1 unit, that would equal a 0 pair because negative 1 plus positive 1 equals 0. So if I have 3 negative units on this side, I'm going to add 3 positive units. And then all of a sudden, those equal 0 pairs, so those essentially equal 0. So now on this side of the equation, we just have our variable by itself. However, whatever you do to one side of the equation, you have to do to the other side of the equation. And since we added 3 positive tiles to this side of the equation, we have to add 3 positive tiles to this side of the equation. So now we've essentially solved our equation. So now on this side we have P equals, and then if we count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'll draw 13 tiles out. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our variable P equals 13. And just to double check our work to make sure we didn't do any mistakes, I would go back and I'd put 13 in that equation just to make sure I was correct. So if I replace P with 13, subtract 3, and that does equal 10, so we were correct in solving for that. So let's do one more really quick equation. I'm not going to walk through it quite as slowly as before. I'm just going to talk my way through and solve this one using algebra tiles. So my equation is x plus 4 equals 7. So to represent this, I first need to draw it out using my tiles. So I see that I have one variable, so I'm going to draw my one variable tile, and then I have 4 positive units there, so I'm going to draw 4 unit tiles. And then on the other side of my equation, I have 7. So I'm going to draw 7 on this side. 5, 6, 7. And so we need to isolate our variable. In other words, we need to get our variable by itself because we want to solve for x. So I see that I have 4 positive tiles, but I need to make those 0 pairs because I want to get the x by itself. So if I have 4 positives In order to make a zero pair, I need to add 4 negative tiles, essentially wiping those out, making them zero pairs. So now I have x by myself on one side of the equation. However, what I do to one side of the equation, I have to do to the other. So since I added 4 negative tiles to that side, I need to add 4 negative tiles to this side of the equation. And now we have, if we were to redraw this out, on one side, on this side, I have my x, I have x equals, and then if I look back over here, 1 zero pair, 2 zero pair, 3 zero pair, 4 zero pair, so what am I left with? 1, 2, 3. So if I just plop the 3 back into my equation just to double check my work, so if x equals 3, 3 plus 4, 4 does indeed equal 7. Oh, sorry, I am not writing what I'm saying here. Let's try that again. Okay, 3 plus 4 equals 7. So we were correct in solving with our algebra tiles.